We last finished off by graphing these logarithms. We answered all of these questions. Let's go ahead and sketch these guys. All right. We're going to go ahead and rather than sketch them by hand, we are going to use our graphing utility to sketch them. So you should have a graph on your other paper. It should look like this. Let's go ahead and put those into our handy-dandy graphing calculator. So you have the log base function. You can go in and just hit log base. And these are log base 1/10. They're really weird. Of x, right? But remember, so that's what that looks like. Remember though, I'm going to show you guys how to do these so that you can do them in any calculator. You don't have to have that log base function. So remember that we can change the base of this thing. Let's go ahead and do that. And I'm going to write that over here. Remember, to change the base of a logarithm, we can say that log base 1/10 of x is going to be log base 10 of x. Remember, this one goes on top over log base 10 of 1/10. That one goes on bottom. Right? That is how you change the base of a logarithm. So we changed that from log base 1/10 to log base 10. So let's put that in here. So that's going to be log base 10 of x divided by log base 10 of 1/10. And I should have some overlapping graphs if I did it right. I do. Yay, they're the same. Right? We have effectively changed the base. So now I'm going to go ahead and I'm going to enter log base 1/2 of x and log base 1/5 of x in there, but I'm going to use the change of base formula to do that so that we can do it on any calculator that we want. If I want to change log base 1/2 of x into log base 10, that's going to be log base x divided by log base, and we're going to put what the actual base was, right, in our denominator. And there we go, we have that one. All right. Okay, so let's do the last one, log base 1/5 of x. So if I change the base, I'll put the log base x on top. And I'll put the log base 1/5 on the bottom. All right, y'all. What is happening there? You're right. This function is constantly decreasing. That's true. Right? As x increases, the function f of x is constantly decreasing, or g of x or h of x in this case. Let's compare it though. So these are our three graphs, and then previously we were looking at these three graphs. What type of transformation has occurred here to go from these three graphs to these three graphs?
Negative.
Think about. Okay. I like that. I mean, yeah. Think about geometry, right? Remember you guys had your different types of transformations. You have translations, reflections, rotations, dilations. Which one of these is this? So dilation would go like that. Let's look at it. Dilating. Exactly. Does it look like we dilated? So yeah, this one.
It's a reflection.
Heck yeah, it is. A reflection about what line do you think? That's right. And that's why when you said negative, I said, yeah, because I mean, if you take a function and you put the -1 coefficient, right? If you make it negative, it reflects it about the x-axis. That's what happens. So. It is a reflection. I believe that's a question we need to answer. Also, guys, and I hate these things, darn it. Aw, that's sad. I actually want to do this one. I'm going to write it on a different page, okay? All right, so you're going to say it is a reflection about the x-axis. Hey, what's another name for the x-axis? A lot of people, this one isn't plainly obvious to. But isn't the x-axis also the line y equals 0? So it's a reflection on the x-axis or the line y equals 0. Okay. Why is that? It becomes a reflection about the x-axis. So it's letter B. If we have log base 1/10 of x, we used our change of base formula, right? To say that this is log of x over log of 1/10, right? Log base 10. If we use our properties of logarithms, we can write that denominator as log base 10 of 1 minus log base 10 of 10. Right? Yes.
So our calculator does the majority of the work. It's just sort of.
Your calculator won't do this.
Won't do this?
No. Your calculator will do all the graphing for you. But as far as the explanation of why that graph is a reflection, this is it right here. Why is log base 1/10 of x a reflection of log base 10 of x, right? Why is that a reflection? And so we can use our properties of logarithms to actually show this. What is log base 10 of 1? Remember how we think about that? We say 10, so what power is 1?
0?
Yeah. What about this one? What is log base 10 of 10? 1. So I just divided log base 10 of x by -1. What happens when I divide something by -1? It makes it negative. And doesn't it make sense that negative log base 10 of x is a reflection about the x-axis of positive log base 10 of x? Just like right, if I had f of x equal to x squared and g of x equal to negative x squared, this is a reflection, right? All right, let's graph these things. Again, we're going to use our handy-dandy graphing calculator. So on your next page, you have so we're going to look at them and figure out what in the world is going on with these. So the first one we have is log base 10 of 10x. Let's compare that right away to log base 10 of x and see if we can make some sort of a conjecture about this. What does it look like? You said parallel. That was kind of an interesting word to use. Huh? K is, yes. It looks like it's a horizontal shift. Let's check the others and see if that's true. So the other one's a little more interesting to do because I have to use my change of base formula. So log base 2 of 2x is the same thing as log base 10 of 2x divided by log base 10 of 2. Right, using my change of base formula. And we're going to compare that to log base 2 of x, which is just log base 10 of x divided by log base 10 of 2. Again, just using the change of base formula. I think we've seen again, it looks like it's a translation, right? Yeah. We're translating up 1 or 1 unit in the y direction. Positive 1 unit in the y direction. I don't think we need to do the other one. I think we determined that that's what's going on. Alright, and I am actually going to just do that. It was a vertical translation, right? And then I'm going to actually do this work right now because I don't... Oh well, ignore the fact that that's there. Let's look at it. Okay. What is log base 10 of 10x? Can't I write that as log base 10 of 10 plus log base 10 of x? And what is log base 10 of 10? 1, right? Doesn't it make sense that that would be a vertical translation, right? What happens if you take f of x equals x? What's the difference between those two? Your y-intercepts change, right? This one has a y-intercept of 0. This one has a y-intercept of 1, which means it's just been shifted up 1. That's awesome. Alright, so that is it for lesson 17. Your homework is